We're not doing color blending today. I think what we need some type of basic UI. And it's not something that it's not something I want to do. But, if we don't do this... Hold on. I gotta finish up some notes for a second. Okay, so the thing is that... close. If I can't use the editor, no one else can, right? Obviously a very opinionated statement, but the idea is that if I'm the one who designed this, and I don't know what the hell I'm doing, then no one else is gonna know, right? Let's delete this. So with that said, we need to make sure that the engine is usable from the standpoint of, you know, anybody else besides me. So let's start opening up our files and let's kind of put everything where it needs to be and then figure out how the heck we're going to make a UI. I don't really care what I put over here. Okay. Okay, so let's just give this a run first. And actually, let's turn off some of the unit tests. So open... And then go on lib, and we have test killer, I think it was called, or kill test. Yeah. And in here, I believe we need to PAINT5D off. Okay, yeah. So we turned off these tests so that those tests make it so that the project takes forever to start up. So I'm thinking we need some type of destination rectangle. Like, instead of a viewport, it could be like a UI rect, maybe. So we could say, instead of viewport, we could say UI, UI something, I don't know. But we could call it, like, UI, or UI rect. Something like that, I don't know. But right now, we're thinking, okay, we have some room on the sides, right? So maybe on the sides, we create some type of user interface rectangle thingy-mabobber, right? And we try to fill it with, like, little buttons and whatnot. Okay, but before we even get ahead of ourselves here and figure out that, let's think about, well, what do we need for... also, hold on. I need to go to my dashboard so I can see who's talking to me. So I am sorry that if you just sent a message to me a few minutes ago, it's been like 4 minutes so far. If anybody has sent me a message, I haven't seen it. So it is video 173. Okay, so it's video 173. And what do I need in terms of a user interface? Well, the first thing I know is that I want some type of button that can toggle. I need toggle buttons. And I need them for each layer that we have, right? So we have 3 layers. And these are like toggle buttons, right? So, toggle buttons. And so hopefully, can we do this all in terms of like buttons, or do we need like, We're assuming buttons. I don't really want any sliders. Let's not worry about any other type of UI elements. Let's just worry about buttons, right? So let's say we have like a user interface rectangle, right? So we have like a UI rect, UI, so maybe like P5D, UI1, and keep them like one based so that actually, what is VP0? Destination screen viewport. Okay. So there's going to be more than one destination, depending on how many user interfaces we have. Okay, so we're going to make the user interfaces one-based. And I'm thinking maybe UI rect, P5D UI rect. PAINT5D user UI rect. Right, something like that. And within that rectangle, if we're inside that rectangle, then how do we partition what's in there, right? So I know we want some toggle buttons for the different layers, right? So we have like we have 3 different layers, right? So we could one index them for the user. And what does the data for that look like, right? So we have like define AAC 2020. I don't know, UI recs? 1, 2, 3, 4, 5, 6, 7. UI recs. So maybe we have a thing called UI recs. And in UI recs, we have UI recs, P5D, UREC, UR1, maybe have texture as uniform location, right? And then this is the rectangle, right? So maybe we have something this, right? So the namespace, project namespace, sub namespace. What is this? This is the location of the UI rect within the texture as uniform stuff, right? So so we could say so this could be specifically for PAINT5D, right? So this could be... That is kind of long, though, isn't it? Right, so the idea is... here's the main namespace, here's the library namespace, here's another sub namespace saying, hey, this is a UI rect for Paint5D, and it's the location. It's location, and this is the actual rectangle object name, right? So, you know, it's like rectangle name, P5D urec1, right? And then editor name is Paint5D, right? So something like that. So the editor name is Paint5D, the rectangle name is this, right? And then we have something like TAUFRAG, texture as uniform, location, 1D on texture, right? So this is the actual location where that's going to be stored, right? Okay, so we see that this is obviously going to get out of hand really quickly. So we want to think about how are we going to design this so that it's as easy as possible to figure out what the heck's going on. So first of all, let's open up Paint and just figure out, well, what's a decent size for these buttons? So I'm thinking, you know, 8x8 is a little bit too small. 16x16 usually gets us like everything we need, right? So we do 16x16. We can probably get like one very high quality letter. But the thing is that we also need to be able to write stuff. So maybe we got to think in terms of maybe like 8x8, right? Maybe like we can have like glyphs that are 8x8, right? Or can we? Like, so I know I did capitals in another system like this. Yeah, so that's not going to work. So 16x16 looks like the best, the smallest power of 2 we can get for like a single letter. It's probably going to be like 16x16. Okay, and yeah, that's the smallest kind of glyph we're going to be able to get in here. And I'm actually thinking more like 16 by, more like 8x16 maybe. Right, like this for a glyph. Right, because then we can do, if we surround this like this, right, and then we have like an A. Right, B, right, C's, D, Z, probably be the hardest one. I don't know. Well, actually, let's go look at the font that we already have in one of our systems for like one of the old codes we wrote. Maybe we want to stick to that. I don't know. We want it to be as simple as possible, though. So I'm thinking, you know, having letters makes things easier. Right? If we have, like, letters, right? So how about 16, and if we duplicate that, 16, 32, 64, 64. So what if we have 64 by 64? Well, the problem with 64 by 64 is, I'm thinking 1, 2, 3. Actual size. That's gonna get very big very quickly. Tooltips would probably be where it's at for that. Yeah, tooltips might be what we kind of need there. I think we're gonna have to rely on icons. I think trying to do anything in terms of writing text is going to be kind of difficult, and we want to kind of figure out like a icon system, and I don't know. Well, let's think about the smallest possible character set we can write. So first of all, I think 8 by 8 probably not, because there are certain characters that probably can't be written at 8 by 8. I don't know. I don't know what we're gonna do for this, because we just want something rudimentary. Well, what do we really need? We need we just want a whole bunch of buttons that are either on or off for now. And in terms of like a texture memory for that, I really don't want to worry about textures for this, right? So if we just want to make some very basic glyphs, maybe if we want to make some very basic glyphs, almost think that something like 9 by 9 might be okay. So an odd number actually might be the best here, unfortunately, because then everything can be nicely centered, right? You can find the middles very easily, right? So like a 9 by 9, right? And or what if we did, let's say we want everything to be in powers of 2, but we want like a 1 pixel padding between everything. So maybe instead of 16 by 16, we say 14 by 14. Right? So 14 by 14. And we build in a 1 pixel padding. And then we can do, right, that even looks like more room than we need, right? Hey, Oh, cool. Nice. Let me go check that out. Let me view. Let me zoom out here for a second. Yeah, I am trying to figure out how to make a basic UI. Let me click on your stuff though. Hold on. Let's go check it out and see what we got here. And hopefully my stuff might crash if I... Okay, so we got a little star field. We got, what, 3 layers? No, 4 layers. Wait. Hold on. I'm going to count. 1, 2... 1, 2, 3... Okay, hold on. I'm going to get this. 1, 2, 3, 4. 4 layers? I think there's 4 moving layers, and then there's 1 static layer. So I think there's 5 layers total. That's just, I'm guessing from what I'm looking at without looking at the code. Alright, cool. And so, drawing points is actually kind of tricky in shader code. I know I've seen the formulas before for it, but it's, it can be really tricky, right? Because shader language, right? You have to go for 1 pixel, is this pixel on screen within any of these stars, right? And that can be very difficult to do in a efficient way, right? Because you don't want to just for 1 pixel on the screen, you don't want to loop through every single possible star location, right? So you have to write the formula in a way where that won't happen. So let's see, we got noise. Okay. Actually, maybe I should keep the chat open in case you're talking about it. Let me split the screen. But yeah, I mean, this stuff, shader code can be really tricky. Have I shown you Art of Code's shader stuff? Like, let me go find them for a second. Art of Code. Let me see if I can find them for a second, because they have a... I don't think that's what I'm looking for. Art of Code shaders. It's like, I keep on referencing this person, but then I can never find them when I'm looking for them. Yeah, this person. So I don't know if you've looked at this stuff. But I might have already shown you that. I don't know if you were working off of that or not, but, okay, parallax star field. Let's go look at this. I can't remember LOL. Scroll to the bottom and make the for loop go only once. I mean, okay. So yeah, why don't we do that? Why don't we kind of mess around with the code and just see what happens, right? Okay, so let's go to the bottom. So we have a loop in here. Okay. So for I is less than 1. I plus equal 1 divided by cell across. And where is this? Oh. Here, why don't I take this? Hold on. I'm going to take this and put it into an actual editor that I know what the hell I'm doing with. Okay. And so we have cells across over here. Okay, oh, cells across is at the top, okay. Cells across 10, okay. So let's just mess with stuff. Let's go like 4. And I think we have to hit enter. I thought there was a, it's been a while since I've used this. I don't think I have to, what is it to recompile? Oh, the play button, yeah, right. Okay, so 4, and then we have, I'm guessing what, we got 4. Okay, let me just put it down to 1, right? And then play button. Okay, yep. So we got one, okay, so there's literally one, for every layer there's 1 on the screen, got it. And then this would be for every layer there's 2 on the screen. And then etc. It also seems to like change the scale as well, but of the star points, but okay. But now that I'm looking at this, I actually think maybe I counted horribly wrong, because I actually only see 3 layers, right? So I see a fast, or maybe not. Wait, fast layer, I still don't know. Oh, wait. Anyways, let's look at what else we got here. Actually, we could mess with more of these things. Noise width. How about 128? Just see what that does. Didn't see anything there. Star radius. Okay, star radius. That seems pretty self-explanatory. Let's double that, right? Oops. Alright, let's double that again. Alright, cool, cool, cool. Let's bump that back up to, like, I don't know, 16 or something. Alright, cool, cool, cool. Obviously, this looks more like, I don't know, confetti than stars. Well, that's just because I'm messing around with it. Okay, so we have, like, some noise. I can't say that I know what these formulas are right off the top of my head. So UVC, is that like, UVC, UV coordinate, I'm guessing? I saved it now with new setting. Read chat, man. Okay, I'm over here. Yep, okay. I'll click that, yeah. Leave. Let's put this over here. It's hard because I can't see the Alright. Oop. Okay. UVC is UV within the cell. So it's like 0.5 at the pixel is halfway through the cell. Okay, I got ya. Click the link I put, or maybe refresh the shader toy page. I think that's what I clicked, but let's copy that. And let's put this over here for a second and see if that's correct. Okay, this is what I have right now, from what you posted in the chat. I updated the code, so there's one layer. Okay, yeah, because everything's moving together. You'll see the single layer parallax thing. Yep, okay, yeah. So I see what you're talking about because there's only one layer moving together. Or is that one layer moving together? Because I see those... my eyes are playing tricky things on me because I kind of feel like these things are moving. It looks like there's two layers. You'll see single layer parallax. Okay. Look, stars are moving at different speeds even though there's one layer. Okay, yes. Okay, so there's one layer, but we still have different speeds. Okay, okay. Alright. So my assumption was, you know, everything moving the same speed on one layer, but from what you're saying, that's not kind of like how you designed it. Okay. And what do we got? Oh god. Oh god, this Shader Toys UI doesn't like it when I... Okay, let's move this up here for a second. Okay. So we got two noise channels. So it's like the illusion of different distances without using different layers. Got ya. I'm like shuffed about it. Shuffed. I'm pretty new to shade. Yeah, shaders can be pretty crazy stuff once you get pretty deep into it. I haven't done too much with shaders. I know I'm writing all my code. Oh, Shuffed is proud. So you are from the European Union, right? Or at least that sounds like some Euro slang. Alright, main image, frag color, max resolution, gets greatest dimensions of viewport, the color to output, vec3, final color, the UV of the fragment related to the cells, kind of, like 0.5 is halfway through cell 0, got it, star chord, frag chord XY divided by max resolution times cells across, the camera position at any point in the simulation, okay, cam path equals vec2 I time times the sine of I time times simulation speed. Okay. Right, so I time times the sine. So we have some oscillation here. And the oscillation is just on the y-axis, yeah, because it's I time, yeah, because I time x. So it's moving linearly on the x, and then on the y-axis we're going like up and down, so the camera's kind of moving up and down. Can I actually see that? Yep, okay, I can see that, yep, I can see that. Times the simulation speed, okay. And the camera position equals the cam path, okay. Create each layer of star fields. Still looks good with one, but more is better. TBF. Hold on, I have an abbreviation for that. TBF. I know, because we said this before. TBF means to be fair. Got it. Okay, TBF, to be fair. So let's see. Yes, yes, yes. So it's like the illusion of different distances without using different layers. I'm chuffed about it. I'm pretty new to shaders. Chuffed like proud. UK laughed my ass off. Yeah, so the path waves up and down. You could set the X of cam path to cos I time, and it will do a neat little circle. Yeah, I would assume there would be like a circle, right? Because if you do... I'm not very good at trigonometry, but, you know, I know enough to get by, so I know that cosine and sine together help you make a parametric circle. Usually I remember the formula as, like, y sin, as, like, a little phrase, y sin, so I can remember that it's x with the cos and then y for the sine. Technically, you don't have to do it that way, because it just changes the direction in which your circle rotates, right? Like if you're creating a parametric circle. Okay, TV stand. Looks like I have to do some chores really quick. But let's finish this up first. Yeah, so the pathway is up and down. Yeah. Okay, cool. Let's see what we got here. Create each layer of star field. Still looks good with one, but more is better. Yeah. Okay. And then here's where we did this like little loop. Cam position equals the cam path. Oh, okay, interesting. So this one isn't, this assignment here isn't necessary, right? Or am I reading that wrong? I think I might be reading this wrong, but I'm thinking we just need to declare a cam position, but we don't actually need to assign it there, right? Because it's doing the stuff in the loop. I think I could be wrong. Yeah, no problem. I also like to read other people's code, even if I don't understand it, just so that I can get used to it, because it's like, I'm good at writing code, I am not good at reading other code. A lot of times it's because, like, you know, sometimes I only understand math when I only understand math, like, when I have, like, visuals in my head when I'm writing down the formulas, but then when I look at other people's math, I'm like, I don't know what that means. Division? Heck if I know how that works. Multiplication? Heck if I know how that works. Like, it's almost like you have to... I almost think that maybe you have to read enough people's code to where you can have pattern recognition of certain formulas so that you kind of, like, just know what's going on by being able to recognize certain mathematical patterns, I'm guessing. I don't know, but I can never understand what's going on when I read other code. Which is why comments are nice, because the comments are really what's going to tell me what's going on. Cam position, cam path, plus some vector multiplied by I. Okay, so we have some type of offset on the x and y that's based on the layer that you're on. Okay, final color, right? Because you don't want all the layers exactly overlaid, otherwise you wouldn't see anything different. Or hold on, is that true? Oh, wait. Because the way you're doing I isn't being used as an index accessor like I usually use I. It's a different scale factor. So not only is this I going to change where you initially paste the different layers, the positions. They're not going to be pasted directly over each other. It also affects how fast those different layers are scrolling at. It's making so this right here is affecting both making sure those layers are not overlaid over each other, and it's also making sure that those layers scroll at different speeds. Okay. Final color plus equals max star field, star chord, cam position, radius, and then 0. Okay. So that is a truncation, or I always get this mixed up, so I have to think about it. The max between 0 and... Okay, so you're just making sure it doesn't go negative. Got it. You're making sure it's positive by maxing with... Well, hold on. Did I get that wrong again? The max between 0 and... This would be... Oh, no, you're taking everything that is negative and... Negative to 0, right? Okay, hold on. It's like, why don't I know how to do simple stuff like this? Because I've written plenty of code like this, but I always have to think about it. So the max of this with 0. So you're going to take whichever one of them is highest. Okay, let's just draw this out for a second. Okay, so if we have, like, -1, or -2, -1, and then we have 0, and then we have +1, and then we have +2. Okay, and we're taking... Which one? Where was this? Okay, let's not worry about the plus minus. I'm just trying to figure this out. Okay. So when I is 0, it just creates that static layer of stars that don't move. Yeah, I is like a scale factor for displacement, kind of. So greater I makes the stars on that layer move more. Okay. So, let's say we have... So -1 and 0. The max of that is... The max of that is, 0, right? Okay. And if we have 0 and +1, the max of that is 1. Okay, no, it is keeping it positive. It is keeping it positive, yeah. So, yeah, I don't know why I can't, like, wrap my head around stuff like this. Like, now, if you do stuff like this, you just recognize the pattern, and you know that, oh, you're keeping things positive, right? But, like, for me, it's, like, positive or 0, right? Yeah, well, I mean, it's, what do you call it? Idiomatic? For... a lot. Yeah, I mean, it's not, it's one of those things where if you are writing a lot of code like this, and you're writing a lot of code, eventually, when you're, like, really in the flow of writing code, there is a good argument to say that when you're really in the flow of writing code, the typing speed can actually be a bottleneck. And with that, that means that writing comments for things that should be obvious is kind of like a bottleneck, right? Where it's like you could write one more line of functional code, or you could write like a comment, right? And so you could probably double your speed by omitting a lot of comments. And something like this, if I were to write this all the time, then I would recognize it immediately, right? Because all I gotta do, right? All I gotta do is be able to remember, okay, max in 0 means I'm keeping things positive, right? And then, right, and the opposite of this is, right, min and something, and then this would be keeping things, what, negative, right? And then, what is it? Or min some value, and then some ceiling. And then you could do like, a lot of times I do code like this, right? So I wrote stuff like this where you have min some value, some ceiling, and then you have some floor, right? And it would be easier like this, right? So you do something like this, right? So you want to, when you want to truncate between two ranges, right, you do something like this, right? So you have, it's a max min kind of formula. So you have max and min, and you use max. The thing is that it's kind of inverted. So it always messes me up because it's inverted, right? So you use max with the floor, right? So you use max with the lowest value you want, and then you use min with the highest value you want, right? And that's all like inverty world, right? So it's like it takes a while to like wrap your head around that. But like if you're doing this all the time, right, you can just look at it and you know what it does, right? That's what I'm saying about like pattern recognition, right? When you don't understand people's code from just looking at it, it's because like to understand this in the terms of just reading the code and knowing what it does, you actually have to just be able to recognize this pattern, right? For me to kind of like compute it, right, and diagram it out, if I have to get to this level and diagram it out and parse it to that level of understanding, then I'm not going to be able to fluidly read through the code and understand it, right? Like there's certain things in code where you just have to recognize the pattern and know what it does. Otherwise, you can't read the code fluidly and know exactly what's going on, right? Because for a kind of a what do you call it? For a fluent understanding of code, you can't reevaluate the logic down to its deepest level for each line you're reading, right? You just have to look at this and go, oh, I immediately recognize this pattern. I know it's capping the range between a minimum and maximum, right? You just have to know that, right? Without reevaluating it and thinking up all these diagrams in your head, you just have to read this, look at it, and remember that, oh, I solved this problem before, I know this is a cap between a min and max, and you just have to take that at faith, right? Like, faith is a kind of weird word, but I think you do have to use faith in mathematics, which might seem kind of weird, but it's like faith in yourself, right? So you have to compute this like this, and then you have to remember what this was, and you have to have faith in your own memory, in your own cognitive ability, that, oh, I remember what this is. Because if you lose that faith and you lose that confidence in yourself, then every time you look at a single formula, you don't have any confidence in yourself, so you have to go back here and reevaluate it at the deepest level, right? So at some point you have to read code fluently, you have to just, take it at faith that you remember what this does, and then just keep on going as you're reading, right? I don't know if that makes any sense at all, but I definitely noticed this with myself and with math class. Like, I always had to reevaluate things. Like, I'd always have to check proofs to make sure that formulas work how I think they work, and reevaluating everything like that can be very expensive. Anyways, let me go read what you said there. Then I have to go move some furniture. And then I'll be back relatively quickly, I think. Pretty much the reason it's a max thing with 0 is because stars ended up having negative brightness values around them, and thus actually darkening other stars if they got close, so I set them to be 0.0 at minimum. Yep, okay, that makes sense, yeah. Yeah, I would probably make a few functions called min-max or something that does that. Using the min and max functions, yeah, for real, right? It's like in graph stuff when you want to shift x along by 2, you subtract 2 from the equation. Yeah, like with with graphing calculator kind of stuff, there's a whole bunch of things where once you're messing with graphing calculators on a daily basis, you just do these transformations and you don't even think about it, right? So you're like, oh, I want to squash the graph. Okay, divide. Oh, I want to stretch the graph up on the y. Okay, I'm gonna multiply, right? And then shifting. Wait, shifting is inverted, right? Yeah, because if you want to shift along the x, you subtract 2 from the equation. Yeah, or it could be thought of if we want the graph to start scrolling to the left, do we subtract or add? I don't even remember. But yeah, it's unintuitive, right? So you just have to get in the hang of it, right? You have to understand it at a you have to understand it at a fluent level, right? Like when you speak English, right? You can use all the words properly, but if someone were to ask you what any given word meant, you'd have to like stop, pause, and like think about it, right? So you can think about that the same with like formulas in programming, where it's like you just use them fluently as you're coding because you know what the heck you're doing. But if somebody stopped you and asked you what the heck it did, you'd have to think about it, you know. Um, uh, to move some furniture. Okay, I'll and maybe 20. Um, yeah, maybe 20 minutes. I'll be back. But yeah, I have to move some furniture. And then I'm gonna think more about like UI stuff. And also, before I go, let's go take your shader thingy, my bobber. Let's go take your shader. Where's your shader thing? Let's go take your shader thingy and let's go put that in my notes. And then we'll let's just go put that in my notes. Okay. And then yeah, I gotta do yeah, I'll see you when I see you. But yeah, I gotta take a break. If you're not around when I come back, that's cool. Just updating my Oh, crap. Yeah. So. Sorry, I'm just not with it today. Yeah, so all that stuff, it's like I have the UI, I had it up there, and then I didn't see that everything I was looking at wasn't, god damn it. Yeah, I feel like I need more caffeine, but I try to only drink caffeine on Monday, and I should just say screw it. I don't know, man. I think that, okay, so no one heard anything I said. So let me go over your question on the, yeah, Skype screws me over. Also, I think, well, Skype screwed me over yesterday and blacked out my screen. I think this was just me being stupid. But yeah, Anyway, let's move on. So, you were talking about like how to make a tile map, and it looks like you want to pull from like Google Earth or some type of Google service, right? Because you want to pull like GPS coordinates. So somehow your C code is going to need to get access to like the Google API. So I know you need to do that. I don't know exactly how you're going to need to do that, but obviously you need to be able to make API calls to some type of Google service. Now I don't know how you do that in C code. I know how you do that in JavaScript, but if you're doing, Win32 API, you need to figure out that in C code. The next important thing I'm thinking about that you're going to want to do is the tile map. The render view for your tile map is going to be square, right? It's going to be these square tiles, and you need to know how to make a basic tile map. But when you're pulling from Google Earth, you got to think that each little cell on Google Earth is not going to be a square polygon, right? It's going to be a four-sided polygon, but it's not going to be square, right? Because it's mapped onto a globe, right? So everything gets tapered when you get near the poles, right? So you need to somehow take a cell from Google Earth where the lines of these cells are parallel to the longitude and latitude lines, right? And so you want to somehow select those cells, and then you want to unstretch them and map them onto completely square cells on a tile map, right? And that's not too hard, right? You just have to do some linear interpolation, right? So you have to take a, you could take a unit square. So you could do something like, so here's what I'm thinking. I'm thinking you have, on your tile map, you have like a square like this, right? It's completely square. Well, imagine that this is completely square, because obviously I'm just writing in a text editor, right? You have this completely square, and then over here, you have something that's like pulled from Google Earth, right? And since it's pulled from Google Earth, the latitude and longitude lines are kind of like this hyperbolic geometry weirdness, right? And so what I'm thinking is you need to map from here to here, right? So you could say, you could make this a unit square, right? So this could be like 0.0, and then this could be 0.0, 0.0 right here, and then down here could be like 1.0, 1.0, right? And then over here, you'd have to figure out what the hell this is, right? So you could, and I don't know exactly how you're going to figure that out, right? But you have to figure out that this is like, that maybe this is 0.0, and this is, 1.0, right? So 0.0 to 1.0, but maybe like over here on the x, it's like, negative 0.2, and then this is like positive 1.2 or something like that. And you got to figure out, like, you have to figure out the coordinates for this, and then the coordinates for this, and then map from here to here, right? I'm not sure exactly how you would do that, right? But you would scan through, right? You would scan through this polygon, right? And you would, this scan line here would map to here, and this scan line down here would map to here, right? Somehow. I don't know exactly how it would work, right? There's a whole bunch of weird details, but that's like my initial thought of how to do it. Now, you might want to think that, okay, well, this is going to be difficult, so I would think try to just make a tile map. Try to just make this part. Just try to make the normal tile map with, like, some debug data in it, like maybe just, like, you know, tiles can have one of 4 different values in them or something. And as you're coding, open S3map. Let me see what you got. Let me go check that out. Let me close this. Because, I mean, you may have done... You've probably done more research than I have on this, so I'm just giving you kind of like my... Oh, OpenStreetMap, okay. So this is like an API. How about... Let's not be that specific, I guess. Okay, so also, like, I don't know what format the data's in, right? Couldn't find any info for my case, right? So you're trying to pull data from here, right? And you're trying to map it into like Win32 code. Yeah, well, it depends on like how. And right, and this data is probably like some type of it's vectorized somehow, right? And I don't even know the format it's in. And I've never used OpenStreetMap before. But I guess the question would be, I guess the question you're gonna have to ask yourself is like, how the heck do I use this API and get a rectangular, a small rectangular bitmap, right? So we want to somehow figure out for, like, if I take a kind of a rectangular region of, let's say I have like, let's say we have, instead of these being kind of these normalized points, let's just assume that our rectangle is like 4 GPS coordinates, right? So we want to like figure out, okay, how do I get like 4 GPS coordinates on here, and then somehow, somehow get the rendered pixels, right? I have no clue. I have no clue how you do anything like that. Not all the data. I just want the simplest, not all the data. So what are you trying to get? Are you trying to get, like, what's the final, what's the, what kind of data? Like, line, streets, I just want to put location of earthquakes, volcanoes. Okay, so you only want points. Okay. Okay. Got ya. And you're trying to make a map of this, and you're doing Win32 code. You're trying to make a tile map, and it's just going to be points. Okay. And okay, and you're customize the map for your uses. Now, are you trying to... So with this, what data are you trying to extract from here? Like, I don't know if I can help you much, but I do want to at least understand your problem. What data are you trying to extract from here? Are you just trying to get something so that people can visualize the topology? Like, if there's, I mean, there's not going to be a volcano in Michigan, but, you know, if there were a volcano in Michigan, are you using this surface so that you can render Michigan, and then you have another data source that you're going to use to plot the volcano somewhere in here, or what are you using OpenStreetMap for, so I can understand this? And I don't know if I can help, but maybe I can help you. At least maybe I can help you think through this, but I don't know if I'm going to be very useful. Now, I think just to put my data. Okay. Okay, so I don't need the other stuffs. Okay, so when you say put your data, are you saying you want to register volcano and earthquake locations with what is this? I just want to make sure I'm understanding that. And I'm not sure how you would... Have you used an API before, right? Because you have to figure out how to, like... well, let's look and see if they have an API, right? So, let's go take this and say OpenStreetMap API, right? Let's go look for that. And let me go put this back up here. Okay. Got ya. So I'm not sure how you would register that, but let's I don't know, let's go take a look and see what we have in here. Has an editing API for fetching and saving raw geodata from to the OpenStreetMap database. This is the entry page for documentation. If you just want to embed a map into a web page, you don't want this API. Use a web map framework instead. Alternatively, consider the Overpass API, which provides read-only API access. Okay, so... Yeah, okay, so you are having... Like, I'm gonna copy this. Yeah, so I don't know any C library for that, right? Because the only API call stuff I've done is with JavaScript, and I use basic XML HTTP requests. So I guess the question would be XML HTTP request library C, right? So you would need some type of library for an XML HTTP request, and you would want it to be able to do it in C code, right? I used OpenStreetMap and Android, and it worked well. Yeah. So C, send XML HTTP request. I have no clue how you do that in C. I know you would need some type of library. And get response. Demonstrate how to send an HTTP XML request and retrieve the response. And what is this? Where are we? Like, what is this? What is this? What are these headers? Where am I? Chillcat C language examples. Home. What is Chillcat? Wikipedia. Chillcat tribe and related uses. No, that's not what I want. Computer. No. Nope. Let's take a look here. Probably not. Or I guess maybe, I don't know. How do you make a HTTP request with C++? Okay, well, not quite C, but it might lead us on the right path here. I know there's no built-in support in C. I wouldn't imagine it would be true with C++ either. I had the same problem. libcurl is really complete. There is a C++ wrapper. Okay, so libcurl might... I think that stands for... curl, I think, stands for CURL, I believe. Okay, let's see. I use OpenStreetMap in Android and worked well. Another way is to use the Qt framework. Qt, for some reason I thought Qt was like what? Like, I thought Qt was like, embedded, not embedded, Objective-C Apple stuff. Or is that Swing? I don't know. OpenStreetMap is embedded with it. Okay. Oh, it's cross-platform. Okay, got ya. Uses some modified C++. I'm gonna say use whatever gets something working. Like, whatever... Like, it doesn't have to be perfect, right? You just gotta get something working, and then maybe later you decide, oh, it was a horrible way to do it, but you got it done, right? And then you can figure out how to make things better the next time round. But if you try to do everything in a perfect way, and then you never get anything done, then you have nothing to improve upon, right? You can't have anything to improve upon unless you get something working. So, I mean, I would choose whatever feels like the easiest way for you to get started. And I don't have the answers for you there. Now, I mean, I guess I don't have all the answers, but I think libcurl might be a way to go. Because it's, C code, I believe, and I think you can do XML, HTTP. So let's see, HTTP post, HTTP put. Yeah, so I think that with that you could make some web service calls. So it looks like this could be used to make some web service calls. API. Use libcurl with the provided C API. Okay, let me take this for a second. I'm gonna make a note of this. So libcurl API. Simple HTTP GET. Okay. Okay, so try to initialize it, and if it is a non-void, right? If we actually get something that's not null back, then we'll do some code. Curl easy set option curl option URL. Okay, I did not mean to click that. Okay, so we give it a URL, right? We give it a URL for an endpoint, I'm assuming. Skip peer-to-peer verification. Verify, okay. So some security things. Hostname verification, okay. Some other security things, okay. Okay, result equals curl easy perform the request. Okay. Yeah, so if we just want like a HTTP GET and we just have like a URL, okay, result equals curl OK, fprintf, okay. Okay, so if it's not okay, we'll print off some type of error code, cleanup. Okay, now where is the question is, where the heck is the information though, right? So if we want to do this call, I have no clue where that, curl code, yeah, I'm not sure exactly where. I'm assuming that this has some type of side effect, right? Because it returns a return code, but there must be a side effect that has maybe a payload in it. I don't know for sure, but I would assume that. But I mean, this looks pretty promising. Neon is a HTTP 1.1. Okay. And then let me just make a note of this as well. So Neon does something similar to curl, supposedly. Neon versus libcurl. See if we can find like an example of libcurl neon comparison. Sure. Notes about neon compared to libcurl. There are some notes about libcurl compared against neon. Okay. Okay, libcurl is more portable. Neon lacks support for NTLM. I have no clue what that is. On Windows, it doesn't offer SSL. What's that? Secure socket layers. Built to use NSS. Don't know what that is. It doesn't support cookies. It doesn't support compression, deflating, and it only supports HTTPS as transfer protocol. Okay. And this is Neon. Neon offers web DAV support. Don't know what that is. I found that libneon is actually a bit more efficient, maybe 33% fewer CPU cycles, blah, blah, blah. And really, what it comes down to, though, right? I'm assuming efficiency, I don't think you care about. Efficiency, I don't think you care about. I think that the supported protocols, you probably don't care much about either. You just need can you get a basic working project up and running, right? So, I think doing everything through HTTP should be fine. And so really it should just be like, if you're looking at both of these libraries, and you're trying to choose between them, you know, which one has like the best documentation, which one, I will do it just a GET request. Yeah, so you just need to do things through HTTP then, right? Yeah, so a GET request, you can do that through HTTP, right? Because it's called HTTP GET, HTTP PUT, HTTP post, what are the other ones? Get, post, put, and hell if I know. And later parsing JSON, yeah. Yeah, my guess is, my guess is just go with whatever you can figure out, right? Like, right? And if you're really paranoid, like if you're really paranoid, if you're really paranoid where you think, like, if you don't want to commit, let's say you don't want to commit to one library or the other, you can just make a whole bunch of wrapper functions for everything, right? So that you could, like, if you decide to start with one library and then you might want to change your mind later, you could make wrappers, right? You could make an adapter layer. Right? Like, I think that when people are being fancy and they're talking about design patterns, they'll say, adapter pattern equals fancy words for wrapper code and helper, and right? So you might want to do some type of an adapter pattern, right? Like if you really don't want to commit to one library or the other, and you just want to, like, right, you can figure out, like, you could figure out an interface that kind of works for you, right? And you could write that interface, and then you could wrap whichever of those libraries or some other library that's going to work for you to do what you need to do. But I guess the first thing you want to do is you just want to you want to be able to ping a so you said you're going to use just do a GET request. So you need a hello world that can just ping some type of page that returns a plain text response with a bit of text, and then printf it to the console. Right, so you need some type of proof of concept, just something simple. Like, basically you're going to want some type of hello world, and it's going to be like hello API or whatever, right? And it's just like you start up a program, it pings some type of server, it pings a certain page on some type of server, and that page is like hard-coded to always return some type of string, right? It's not too hard, and I can show you how to, like, if you want to know how to do that from, I don't know how to do that in C code, but I can show you how to set up a REST service on, like, Heroku, and I can show you how to ping that from JavaScript code. And it would be the same kind of thing. Now, I don't think you want to go that deep. I think you just need to. Oh, you know what? Oh god, my. So you should use this. They should have a add-on for Chrome. And Oh, okay. So you already. Okay, you're already there. Oh. Oh, cool. Okay, cool. Yeah, I mean, those are some of my thoughts. I don't really have any more thoughts than that. I mean, I don't really do that much kind of web stuff. And all the web stuff I do, it's just, or actually most, I should say all. Okay, got it. So you want to figure out how to display the map. Okay, well, yeah. Okay, well, let's think about what's the most basic. Okay, let's just say that we have points. Let's just say we have points on a globe, and we want to just... okay. Okay, cool. Okay. I guess let's think about that for a second. And how many frames am I dropping? I am dropping... Okay, okay. So, hold on, let me get some... Yeah, let me get some graph paper really quick. I'm gonna need graph paper, and I'm gonna need to take my camera. Hold on, I'm gonna grab some. I need to turn on a light. What else do I need to do here? I guess I need to take the camera down so that you can, hold on. So let's do... Let's make a new, I'm gonna make a new scene for a second. Okay, hold on. clue if anything I'm saying is anything unique, like to, like you're an engineer, you're smart, you know. So I don't know if any of my insights are actually like things that you haven't already thought of, right? But those are my thoughts on how you need to do what you need to do. I'm going to try to write some more code, though, for my stuff, but those are kind of my insights. Maybe that helped you, maybe it didn't, I don't know. Yeah, my setup is crazy, is what it is. So, anyways, yeah, hopefully that helped. Yeah, hopefully that helped and gave you some ideas of where to go. Because, man, I don't know, we all need some guidance sometimes. Like, I'm trying to figure out how to sell stuff on Amazon lately, and, I haven't logged into my Amazon account in, over 6 months, so I've been locked out of it, and two-factor authentication isn't working. Yeah, I'm having tons of trouble with stuff I'm doing. My desk is super crazy at my job. I bet, yeah. Yep, cables, yeah, all over the place. Yep, I have cables all over the place. I mean, you probably saw some of them, right? Actually, here, let me go show you really quick. You may have not seen the whole thing. Well, let's go to Imgur really quick. Show you what I got. And if you have some pictures you want to show, I'll take a look. Like if you want to, yeah. But here I'll show you what I got. So my Imgur it's not what do you call it? It's not pornographic, but some of the stuff is not completely work safe. Just a warning here. It's like, you know, it's on that edge, right? Like, you know, this is kind of like on the edge of. But anyways, I'm gonna find my or this, right? I think I posted this in the. Oh no! Did I accidentally delete that? No, I don't want to delete that. Escape! Oh god! Refresh! Ah. Okay, hold on. But anyways, I have, you know, stuff like that. But anyways, let's go find. I think I have a picture of my setup somewhere in here. Sexy mummies. Somebody in the cringe group posted like a hair metal song, and then I'm like, oh, I'm gonna find some stuff. Tall vampire lady. This one's one of my favorites. But anyways, where is it? Here we go. Here's some images. So here's my setup from behind. You can see that there's like 3 tons of acrylic behind me. And I'm trying to figure out how to sell that on Etsy right now, but I have no clue how to, right? It's not just about having something to sell. You actually have to have people see your listings, and like I don't have an established shop because I've never sold anything before. Like I have 1 sale and no reviews, so I have no clue how I'm gonna get my Etsy shop working. But I have like 3 tons of acrylic that I want to sell, so I gotta figure that out. And then this is a close-up of the back, right? So I made like a little cage, right? So my little computer is right here. It's like I think it's called like a steam machine is what it was called. It's like actually no, it's called like Zotac Z-Box or something like that. It's like one of those Nook kind of computers, but it's like a heavy-duty Nook, so it's like bigger than a typical Nook. So it's pretty much like a very small tower is the way I kind of think of it, right? I got some rechargeable batteries. I got 3 layers of surge protectors. So here's a surge protector, here's a surge protector, there's another one you can't see. But yeah, I just have a way to get at all the stuff, right? Because to get at all these guts, I got to open up this cage, right? So this cage is kind of on like a zip tie hinge. So this part will open up, and then I can get at the back, right? So this is like a little door. It doesn't look like a door, but it is a door, right? And so down here, in this milk crate here, in the very back, I have a small RAID drive. I have it's 2 hard drives acting in tandem. for data redundancy, and they're back there. They're way in the back. So behind my monitor is actually my bottom monitor is within this milk crate, and then behind the monitor is that hard drive, right? So the idea is that the setup is kind of made in a way where it's a portable setup, right? Because right now, I used to be able to lift this myself, but now that I've torn my bicep, I don't think I'm going to ever be strong enough to lift this myself, which sucks, unless I can get surgery to fix this. I don't know if that's ever going to happen. But yeah, with two people, I could lift this and just put it anywhere, right? So it's like a portable computer setup. What else we got? I think I only took a few pictures, right? So this is, I think you've seen this on Discord. And what else do we got? Same picture, just zoomed in. But yeah, just held together with zip ties and whatnot. Zip ties and milk crates, those are the staples of how I survive. Anything else? Yeah, top view. Yeah, just ridiculously kind of crazy. But I'm thinking about like, so I really like modularity, right? So I like a setup where if if one of these monitors ever goes to hell, right, I can just replace any one of these monitors, right? If my computer goes to hell, I can replace that. I can replace the computer. If my hard drive goes to hell, well, everything's external, right? So I try to keep things on my external hard drives. I try not to keep anything on the actual computer hard drive, because swapping out hard drives is tricky stuff and it's time consuming, and you have to have the right tools. And I'd rather, if my computer bites the dust, I would rather have like everything backed up on GitHub and on my thumb drives, and just be able to just throw out the computer and start over again, right? So I'm not a hardware person, right? So I just want a setup that's really easy to kind of like do what I need to do. Yeah. You use Pinterest? Yeah. You don't really use Pinterest because Pinterest's log in you. With yeah, so the thing is that, and there's actually, yeah, I hate doing that as well. Yeah, I have lost all the accounts that I have ever lost. Well, okay, let's say like 95% of the accounts that I've ever lost. It's because of some. It's not my fault. It's like, I mean, I guess technically That sounds like I have some DSMV psychological disorder by saying it's not my fault, right? Because nobody likes to ever blame themselves. But I really do believe, most of it's not my fault. Like, I actually have the password. I know the password, but then it tells me that I have to use my backup email, right? It says use your backup email, right? You go to your backup email, and guess what? You're also locked out of the backup email, which you also know the password to, but you haven't looked that up either, right? So here's what happens, right? So you try to keep everything separate because you don't like the surveillance state, right? You hate the surveillance state, so you're like, I'm gonna put all my stuff in separate accounts and not gonna link my accounts together. But then you get locked out of stuff because, I haven't logged into this in a year. Okay, password. Use your backup email. Okay, you got another backup email that's disassociated from everything because, once again, you don't want people to track you. So you go to your backup email. You try to log into your backup email, and it's like, sorry, you haven't logged into this in forever, so we're going to have to ask you to verify with your phone number or whatever. And then you try to verify with your phone number, but, guess what? That was a year ago, and you have a different cell phone number, and so you're screwed there, too. And yeah, so then what happens is you have to make a choice of how important is this to me, and now it's like, if there's some things that I want to keep, then all of a sudden if it's important enough for me to keep, then I don't get to have anonymity, right? If it's important enough for me to keep, I don't get to have anonymity, because now, if the only way to guarantee that I can keep any of my shit is to link it to my Google account, right? To say, okay, this Google email address is the backup email for this account, and this other account, the backup email, is also my Google account, right? I have to actually link it all together, because if I don't link it all together, then I'm going to lose it, right? And it's just the design that they have, the design they've put in place. I'm going to lose my stuff if I don't link it together. But if I link it all together, then I don't have any anonymity, right? Like, all my stuff is, like, out there, right? Google knows, those, like if you were to die, like, maybe you would want to, like, burn your hard drive so, like, people don't know what kind of, like, freaky stuff on the internet you're into, but Google probably already knows, right? Because, like, unless you have some really crazy discipline where it's like, okay, I'm always going to use, like, an incognito browser, and then even then that probably doesn't work, because it's not if you use Chrome, Chrome kind of has, like, a whole bunch of privacy invasion things going on, and so you might want to use a de-Googled browser, and then you probably don't want to use Google for searching for anything if you're up to no good, and blah blah blah, a whole bunch of stuff. So, like, Naver, huh? I haven't heard of that one. I've heard of de-Googled Chromium. Oh, okay, it's even called Whale. Okay, that's interesting. Alright, I bookmarked this in my notes, because that's gonna, my internet probably just sucks right now. But yeah, I bookmarked that. Is it Guri or Yuri? Guri, yeah, Guri. Okay, I'll put that in there. Okay. It's South Korea search engine, or it's called Google of Korea. Oh, interesting. Okay. Yeah, I'll keep that in mind. Yeah, I don't know much about South Korea except for that I watched a few interviews of like doctors talking about COVID, like some Korean doctors talking about COVID like a year ago, and like I don't want to get too political, but you know, the if you want to take Korea's word for like what works and what doesn't work in terms of COVID, then as an American, I'm an American. If you're an American and you take the word for what works in terms of COVID, and you take Korea's word for it, which they have some good statistics that say they probably know what they're doing. Well, if you take their word for it and actually listen to their doctors and listen to like what they're talking about, then your opinion on COVID will not align with either the Democratic or the Republican Party. It won't be like if you're, and I don't want to get too much into what those opinions are, but I'm just going to say right now that that I think that Korea knows what they're doing in terms of the like pandemic crisis. I think they know what they're doing, and I think that if you look at their explanations for why they do what they do, if you take it to heart, your opinion on the current situation will not align with either political party, because they're both kind of full of shit in different regards. But I can't really say more than that because I don't want to get too political. Yeah. I don't know about privacy issues. Yeah, I don't. Yeah, but anyways, yeah, it's like, yeah, I don't know. I don't know what to think about it all, but yeah, it's annoying. Anyways, the whole worrying about privacy and not wanting all your accounts connected, and anyway, so I have these constants that they're hard coded into the shader code. And I need some way to, if we go into the Tau depot, let's go open this up for a second. Okay, so if we look at this data here, I have like a table of where, so this PAINT5, this one here is coming from here, right? So I should be directly using this define somehow, but yeah. Yeah. Yeah, like I'm not an expert, but hopefully some of the thought process like helped you kind of think through the problem. But anyways, in here, this is this fragment shader code, and we want to get access to this, right? Now the problem of just smacking it in here is that this code has to execute as shader code, but it also has to execute as C99 code. And because of that, when this code is executing on the GPU, it's not going to know about this, right? Because this right here is, oh, cool. Very cool. Yeah. So, yeah, I mean, you got like a massive undertaking on your hands. So just think of the little pieces that you can use to build up and the little proof of concepts you can do to get to where you want to go, and just work at it small piece by small piece, right? Because that's what it takes to slowly grow something very large, you know? But anyways, this code here, these constants, I cannot just directly include them because of the problem here of this being, if it executes on the GPU, I'm not going to be able to get access to that. So how the heck are we going to solve that problem? So I'm thinking what we're going to have to do is, like, we have these macros for if it's OpenGL or if it's C99 code. I think we need a section for either type of code, and what we're going to have to do is what we could do is we could hard code these values here. We could hard code the values for what these are, and then what we do is we write some tests to check what those are. So let's go into the common. So fragment. So this common shader code stuff here, right? So we're thinking we want this fragcom is kind of like common code that is included before any other shader code. And it's just like common like helper functions and stuff, floor, whatever the heck. So I'm thinking what we want to do is I think we need like a new section in here. This is just what I'm thinking. So we want to make a section where we have constants from here, right? So copied from... this is the only way I can think of it, is that we want to copy some values from over here, right? And we want these values to exist both in the CPU side code and the GPU side code. And because of that, right, we have this if-def OpenGL and then otherwise, C99 code. We want we want these defines to be defined regardless of if it is C99 code or if it's GLSL code, right? And we're gonna say like AAC 2020 fragcom so I'm thinking, do we want to take this whole thing? Or do we want to, like, abbreviate it? I don't know. So fragcom, this is way too much name spacing. But something like this, AAC 2020 fragcom, tau depot sub PAINT5D. And we set it to 1 like this, right? And then or do we want to keep it so that, this name is similar enough, right? So that right here we can see AAC 2020 fragcom, right? So this, and then tau depot sub PAINT5D, right? So, right, so maybe like this. So we have the we have this part of the define that has the namespace that we're currently in, and then sub PAINT5D matches this Tau Depot sub PAINT5D, something like that, right? And then we want to duplicate this, and this one's going to be Tau Depot. Okay. And then we also want to duplicate some of these other things here, right? So if we want to use these other data points, then we want to, we essentially just want to make sure they match, right? So, so let's take this stuff here for example. Let's just steal this stuff here. And God, this is long stuff. Right, this is getting way out of the... how do we want to... something like this. I don't know. So I don't know how these got lowercase like this and these are uppercase. I don't know why that is. That seems like a mistake. But yeah, we want something like this, where we can, we want to know exactly what system this comes from, right? So this is in the fragcom, right? It's in fragcom, and then it's tau sub this stuff, right? Tau depot sub. So. Now, okay, I see. So in here, the subsystem block is the, these blocks here. like this block here, this 0 and this 1, corresponds to one of these blocks here, 0 through 15. Or actually, that's not quite correct, is that? Because this is not sub. This is the tau section. This is the sub section here, right? So, C in, right, so if we look in the data, that's where it's going to be. Okay, so we know that that these two things are coming from this diagram right over here, right? And then these things here, these are not the subsystems right here. These are the variable cells. And these variable cells come from the different cells over here, right? And we got 256 of them, I believe. Variable cell indexes. So these are the variable cell indexes, 1, 2, 3, 4. And subsystem block indexes. Not spelled exactly correctly. Okay. And we're going to make a copy of this stuff, and then the way we're going to verify that these copies are always correct is we're just going to have like a unit test that verifies that these things are correctly transcribed from this file here, right? Which is kind of hackish, but that's the way we're going to get it working. Okay, so right, so tau sub P5D, right? If we're looking at that equals this tau depot.subcell.paint5D, right? That's kind of what this kind of prefix here is kind of means to us, which is kind of like really large, but we need some way to cram it all in there. So we have all this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. And we just want to write a unit test to verify that these transcribed things that we've put in here are correct, and that they properly match what we have in other places, right? So, so all we got to do is let's go into the fragcom and look at the functions, and we should have a unit test section, right? We got a unit test, and in our unit test we have rectangle mapping, and then we'll just have tau depot shader constants. So we also want a way to make sure that the tau depot shader constants are correct, right? And in that, all we're going to do is we'll just say, you know, extern void AAC 2020 fragcom unit test code tau depot check. Something like that. I don't know what to call it exactly, right? But then in here, so a whole bunch of rectangle testing code. This is our unit test section. So let's just say extern void, this thing, and then, was this supposed to take anything? Oh, yeah. So we want to call it like that, and we want to duplicate that and actually call it. So we want to forward declare it, then we want to call it. Okay. And then over here, we'll say this takes a void. Right. And all we're going to do is we're going to do some asserts here, right? So, you know, if, right? So if this thing, right, is not equal to this thing here, right? Right, if those aren't equal, then we got a problem, right? And let's just, for now, let's just throw in some type of no match, like that. I don't really care. And we want... It's gonna get really annoying, isn't it? Can we just do like, so, I don't know, I guess we should put them right next to each other, right? And, make like a little table where we match these together, right? So, I don't know, U32 TAUFRAG, right? I don't know. Table. Table of some number of values equals this, right? And then in here, we just kind of like put the things that need to match right next to each other like this, right? And maybe we make the first two entries, we can make them 0. Okay, so we'll make the first two entries just 0 so that I can just put the commas in front of everything and not have to worry about that, about this. But yeah, we're gonna say that, you know, this constant needs to match this constant, right? And then we'll just kind of like keep that up, right? So we'll just say, hey, we'll just keep on matching from here to the version in the PAINT5D shader, right? In the in the fragment shader for the fragment common, right? So this is from the Tau Depot system, right? And here's the appropriate from the fragcom system, right? Tau Depot sub Tau Depot, right? So we'll just name them like that, and maybe it's not the best casing scenario, but as long as we can connect the dots, know where one thing leads to another, I think we'll be good. And so we can also name this the same as these sections here, right? So we can actually call this right, to call this dex sub whatever the heck. I think that would make some sense as well. Right, so this is dex sub, and then over here is dex var, right? So we can make dex var. And we also have, do we not have a thing called dex tau? Yeah, we have a dex tau as well. Right? And we can keep the same category names as what it is over in here, right? And that'll make it a little bit easier to know what we're doing, right? So in dex tau, right, we only have this thing here. So we have this value, and I guess what would that be? That would be AAC 2020 fragcom, and then we call it Tau Depot, Tau, right? So make that lowercase. So we still want some type of similar pattern here. And because of the way we're doing this, we can say, let's indent this once, and then let's make a note that the so when we're looking at these subsection names, right, they can actually match what's in, we might want to make this kind of like less intense. But these subsection names can actually match, so at vid IID, and the time is 2 hours, 53 minutes, and let's say 54 minutes. Okay. Code comment section labels below match are identical to the comment sections in Tau Depot depot.d._, in case you yeah, so hopefully by making these section names the same in the code, we can kind of understand So subsection names match Tau Depot D, right? And that stands for Tau Depot.data, right? And this is where we wrote this comment initially. And we're just saying that these section names here, right, correspond directly to the section names in here, right? So that we can kind of know exactly how this is all connected. So at the end of the day, we could say, oh god, this is atrocious, right? These names are atrocious. But as long as they work, right, then we're not in too much trouble, right? So the next thing is in the fragment shader common fragment code, whatever the heck stuff we got. Oh wait, wrong shader. Okay, I was like, wait, where is it? So this stuff here, if so now what we want to do is all this stuff here. I guess what we want to do is we want to say, let's change these names here. Let's make these names match as well. So let's go in here for a second, right? So dex tau, whatever the heck, right? That's what this is, right? Yes? No? No, that's not. Dex tau is up here. We haven't actually set it yet. And this right here, we're going to take this and say define make this lowercase. And right, and we're going to set that to 15, right? So this is dex tau, this is dex sub, right? So this is actually dex sub. Right, and then over here is dex var, right? So this is dex var. And then we can just say, we can also make a note here that, the time is 2 hours, 58 minutes, and let's say 32 seconds. Comment sections below match right? So we want to keep those exact comment sections, right? So when we're looking at this code, we can say, when we're looking at this code right here, and inside this section, the comments here, here, and here, these comment labels match these comment labels here, right? And that's by design so that we can kind of tell where we are. But once again, I might want to make these sections a little bit lighter weight so that we can kind of see a visible line hierarchy again, right? So these sections are based on the other sections, right? So a lot of this is just how do we structure the code in a way that we can connect the dots between one thing and another, right? Okay, so we got that. That looks good. The next part is, okay, in fragcom, though, one of the things that's kind of going to annoy me here is or not in the shader, in the actual fragment shader. These are really long, so we want some way to say, we have these different sections for these different macros. So I think we need one more section for, I think we need tau depot. So we need tau depot macros. Like I don't want to do this, but it's gonna be easier this way, I think. And this does create well, hold on. Isn't this already tau depot macros here? Got it. Oh, these are temporary. These can be defined. These are defined and undefined. So these are permanent. These macros are large because they are code base global. Okay, I see what I'm doing. So these macros are large because they're code base global, like all these macros here. But then when we're trying to write code, we don't want to use those gigantic macros. That's going to be annoying. So what we're going to do is we're going to create like another section here. And I really don't care if it's OpenGL or not. So if 1 equals 1, right? So OpenGL or C99 code is what's going on here, right? And I just want to make it obvious that this is OpenGL or C99 code. It's going to be the same no matter what. And what we're going to say is tau 015, right? So we're going to define tau 015, and we're going to set it equal to way up here, right? This tau 015, we're going to set it equal to that, right? So, right, so this thing right here is hard-coded, right? So it exists in the shader code. Now it needs to be exactly equal to the values over on the left side of my screen, but the reason why I have to do it this way is just to make sure that that it runs as both C99 code and as GLSL code. So we're going to do that, and then we want to do it for more of our variables as well, right? So we're just going to take the lists. We're going to take all these lists here. Let's copy this. Paste this over here. Then let's go over here, take this other list, right? Take that, paste this over here. And then what we're going to just say is, right, we have these defines. We're going to define sub tau and sub P5D, right? So sub P5D. So that way we know This is the Tau system, this is the Paint5D system, right? So they're just equal to those things, right? Which is kind of like more indirection, and it sucks, but it's better to have this indirection than the hard coding that we already have. So over here, we're going to say I'm thinking it makes more sense to call it like var doesn't really make sense. I think Paint5D, knowing that it's a Paint5D variable, and this is the variable name it has, I think that makes more sense. And actually, I bet if we look at this, we actually have this as variables in the instantiatable data, right? It's already there in the instantiate, right? So same data, same name. That's excellent, the way we've decided to do that. Okay, so we're going to take this stuff, we're going to put it into the defines here. So in here, let's go throw this in here. And this is still kind of crazy. This is like any more than that, and we would be over our limit here. So then, let's just say, if we want to keep this kind of the same kind of thing here, right, this section here, and do we want to label it like we have been? Do we really want to keep this up? It makes things more verbose. It makes things kind of like more I don't know, man. Right. I think these sections actually do help me figure out where the heck I am in my code, so it's kind of eh. But I think there is a... Oops. I think there is a reason for this. I think that there's good case for why we want to do this. So let's keep it up. Okay. Alright, so we got these names, right? They're, so once again, these section names that you're seeing, 1, 2, 3, at vid IID, God damn it, I can't type. Okay, section names identical to those in file. Right. So I don't need too much commentary. It's just that the section names, these section names below, right, are identical to those in this file here, right? So this dex var 0255 is from here, right? The dex sub, right, is from this dex sub, and then this dex tau is, this dex tau and this dex tau are the same thing, right? And we just want to know that so that, like, when we're trying to connect the dots and figure out where the code how is all the code connected, right? That is a very challenging sometimes. So we want to be able to figure that out as easily as possible. This is going to help us. So the next thing is, right now, the next thing is we still have a problem. Whereas if we don't get these transcriptions wrong, then we're also in some trouble, right? So if we transcribe these wrong, our unit tests, at some point, we can't have a unit test to check, yeah, we can't really test this, right? We just have to, if we get these wrong, if we get these mappings wrong, if we screw up these mappings here, then we're just up the creek without a paddle, and we're in horrible trouble. So we got to make sure this is correct, because these are going to be used in the entire shader, right? So in here, right, and then after we have oh, I see. Ooh, okay. We're gonna put this into a new place, actually, now that I think of it. So this kind of stuff, it needs to... Yeah. Okay. These tau depot constants, let's put them in a new thing, and let's call it, now does tau depot come before everything already? Okay, it does. So in here, we're gonna make something called TAUFRAG. I think, right? We're gonna put in here, we're gonna make something called TAUFRAG. And it's just gonna be the constants, right? Right. So fragcom. Where's fragcom? Frag shader common actually. Well, if we want frag shader common to use this, then oh, I see. So fragcom should really be... If we look at fragcom shader stuff, does it use tau depot? So if fragcommon needs to know where to get certain memory regions, then fragcommon really needs to be Okay, you know what? Now we can keep fragcom here. Like fragcom, but for, so I think we need to just, take some of the stuff that's in fragcom, and it goes into here, I believe, into the other stuff we're cutting and pasting here. So I'm thinking we're going to save this, and we're going to call this, we'll call this, just call it TAUFRAG dot, so this will be like the actual fragment shader code, right? And yeah, it's not going to go in fragcom, right? So everywhere where I said fragcom, that's not going to be the case. We're going to say fragcom is going to be TAUFRAG. Okay. And then this fragcom stuff here, we're going to not do this here. We're going to steal this here, save that, file new, and this is going to be, instead of fragcom, this is going to be TAUFRAG, and tau depot copies match. So we're going to call this TAUFRAG dot functions, right? And it's going to contain the unit test code and all that stuff. And then in here, fragcom, like this stuff here, we're going to gut this out of here, right? And we're going to say that these macros, these tau depot macros here, we're gonna take these out of here. I'm gonna say nope, forget about it, change my mind, and we're gonna put those these macros here. And I'm thinking that we want a top and bottom file. We want to include all these defines, right? But we don't want to undefine them. We want other things to be able to use these defines everywhere. So we really want a so we're going to take this, save this, and then we're going to rename it. And it's going to be a little bit different. It's going to be taufrag.frag.top. So we're going to have a fragment shader top file, and then we'll also have a bottom file as well. So let's just put some blah 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 stuff in here. Let's go into fragcom. Let's go find where we're going to call that fragcom.f, not in here anymore. Oh yeah, because I called it, this is now TAUFRAG. Right, so we're going to steal this out of here. Save this over here. Go in TAUFRAG.f, and we're just going to say, you know, how do we name this unit test function, right? So we're going to we're just going to say this is right here. This is a U32. This is TAUFRAG. And this will be TAUFRAG. And then down here, we'll log the end, close it off, put this on its own line. TAUFRAG unit test. Okay, that. Okay. So we'll make sure the copies match over here. And everywhere we said fragcom, we're going to change our mind on that, right? So instead of fragcom, it's going to be called TAUFRAG. We still have to do the basic work to change these around. Okay. And so, so about TAUFRAG. Okay. So, okay. Hey, how's it going, anime dude? How's it going? I'm working on some. I gotta get going soon, like in a half an hour. But I'm just doing some refactoring, trying to get rid of some hard-coded code, and it's a mess right now. It's a complete mess. Similar to fragcom, except manages access to Tau Depot memory from the shader code. On the shader code. Unlike fragcom, you must include two shader files. One, taufrag.frag.top. I remade Friday Night Funkin'. And that was the thing that's kind of like Rock Band, right? But everybody does like different poses and whatnot, right? Did I got that? Do I remember that correctly? Yeah, show me what you got. I got some time. Okay, so, and then over here, taufrag frag.bot.string. Define your defines. So we want to add the defines, then we want to remove them, right? Defines. So we want to add tau defines And then we want to add tau functions, and then over here we want to just remove the tau defines, but we don't want to do any function removal. We just want to remove the define. So it's something like this. Oh, I just see it post that URL. Hold on, I will check that out momentarily. Yeah, so something like this. And really quick, I want to look at where fragcom is being called from, or where fragcom is referenced in other code for a second. And what the heck? I am not cancel. Hold on. Once I check this, once I know where this is cancel. Got. Hold on. I am not. I don't know what I'm doing today. Search for this, and then once I search for this and find where this is coming from, I'm gonna go check out your URL. But I just want to check this out really quick before I and see if anything is detrimental here. libchan order, fragcom, f macros, Okay, so GPU view. GPU texture Y up, GPU texture view. Okay. Oh, that needs to be changed. Okay. So I think that's good. I think that's good the way I'm doing things. Let's go check it out. I'll finish up my thoughts. After I taken a look at what you got going here. And then I'm gonna then I gotta kind of do. It's 6:03. My shop time is at 7. Today is, or did I miss it? Tomorrow's Friday. So today's Thursday. Yeah, the shop I got at 7 o'clock. So I need to do that. In fact, I might need to leave really soon because I probably need to get some plywood to start cutting, or. I don't know what I'm gonna do. I got a lot of stuff going on here. Can we get this working here, or can we... Sorry, my internet really sucks right now. Yeah. Okay, let's see what we got. And then I gotta get going. I have no clue what I'm doing right now in terms of the shop stuff. I just need to not panic, and I'm trying to figure out how to sell stuff on Etsy right now. So I don't know if you can do me a favor. Well, I'm waiting for that. Let's see. Oh, okay. Well, I guess things are a little bit better, but I still need to get going. And then I'll try to figure out what you got there a little bit later. It also seems like maybe the screen might not. My screen size is a little bit small, and I'm not sure if that is also creating problems, because I assume that there's like a game over screen, and I kind of see some text for a game over, and that I don't quite see it. So figuring that out could be helpful. Making sure that your game kind of like resizes nicely to different size screens and works out would be helpful. But yeah, I need to get on going out of here. But yeah, I'm thinking of yeah, I was looking at sorry, I was looking at, let me go up here for a second. I was looking at this. So Anime Dude has been making like little Scratch games, and so I've been just taking a look at what they've been up to. I want to eventually help Anime Dude kind of like do kind of like some JavaScript stuff, because I could help them get started with some JavaScript, you know, because I know it can be intimidating to do that. Because I think they're doing quite a lot in Scratch, to where it's like they need to branch out into doing some JavaScript or something. It's kind of like when I wrote really crazy rendering code in ActionScript, and it's like, holy crap, the code I'm writing is so crazy that I really shouldn't be doing it in ActionScript, right? I should be using a more serious language, and I think that they're to the point where they're writing a lot of really crazy stuff in Scratch, to where I think that they hit the time where they've done. They're getting so complicated in Scratch that they really should move on to like ActionScript, not ActionScript, but like JavaScript or something like that. But I know it's hard to get started. But I don't mean that in a negative light at all. I'm just trying to give my honest feedback of where they need to go next time, or where the next steps for them are. ASDF. Oh, so it's ASDF? Is that what you're noticing? Let's go open that again. Oh, it's ASD. Oh, okay, ASDF rather than ASW. I think I was doing ASDW. I was using WASD. So that's where I was screwing up. Okay, got ya. Okay, got ya. So it's like this is A, S, D, and F. Okay, got ya.